In this lesson, we're going to be looking at angle bisectors and perpendicular bisectors. Perpendicular bisector is a line segment or ray that is both perpendicular, meaning it forms a 90-degree angle, to and also bisects. It splits into two congruent parts, a segment. Note also that equidistant means an equal distance. Perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. The converse of that theorem says that if a point is equidistant from the endpoints of a segment, then that point is on the perpendicular bisector. Angle bisector theorem says that if a point is on the angle bisector, then it is equidistant from both sides of the angle. And the converse of that would suggest that if a point is equidistant from both sides of an angle, then that point is on the angle bisector. In this example, we want to determine what the measure of MN is. Since N is on the perpendicular bisector, then N is equidistant from M and L. So NP is the perpendicular bisector. Since NP is the perpendicular bisector, then NM is the same measure as NL. So MN is going to equal 2.6. In this example, we want to find the measure of BD, and A is equidistant from B and C. Therefore, A is on the perpendicular bisector. Since AD is the perpendicular bisector, then AD is bisecting segment BC, and BD is equal to DC. Therefore, BD is equal to 12. In this example, U is the UT is equal to UV. Since the segment going down the middle is the perpendicular bisector, that means that U is equidistant from T and V. So you set the two expressions equal to each other, subtract 3x from both sides, and then add 17 to both sides. Divide by 4, we get x equals 26 over 4. And then to solve for UT, we're going to plug in the value 13 over 2. Plug that into n for x into that expression for UT. We get 39 over 2 plus 9, or 39 plus 2 plus 18 over 2, which is 57 over 2. In this example, AC is the perpendicular bisector, so that means that AD and AB are congruent. So we're going to set those two expressions equal to each other. Solve for x by subtracting 5x from both sides. Divide both sides by 3, and x equals 4. So now that we know the value of x, we're going to plug it into the expression for dA. We have 5 times 4 plus 12, which is 32. In this example, BD is a perpendicular bisector, so BA is congruent to BC, so we set the two expressions equal to each other. Solve for x by subtracting 2x from both sides. Subtract 1 from both sides. Divide both sides by 2, and x equals 2. In this example, we have CB is 6x plus 3, and so CA is also 6x plus 3. Let's skip this example because I think that the expressions were given for the wrong sides. In this example, AC is the angle bisector, so CD is congruent to CB. So BC is going to be the same length as DC, which is going to be 7.2. And in this figure, FH is the angle bisector. So EFH is going to be congruent to GFH. They're both going to be 50 degrees. In this figure, KM is the angle bisector. So we're going to set those two expressions equal to each other and solve for A. Subtract 2A from both sides. And then subtract 20 from both sides. We get A equals 6. Plug that value of X into the expression for JKM. And we get 3 times 6 plus 20, which is 38. And in this example, FH is the angle bisector. So we're going to EFH and GFH are congruent, so they're both equal to 4x plus 3. Add 4x plus 3 to 4x plus 3. Set that equal to the measure of angle EFG, which is 2x plus 17. 4x and 4x is 8x. 3 and 3 is 6. Subtract 2x from both sides. And we get 6x plus 6. Subtract 6 from both sides. And we get x equals 11 over 6. Plug that in for x into the expression for EFG. And we get for that angle measure 11 over 3 plus 51 over 3, or 62 over 3. In this example, AD is the angle bisector, so we're going to set BD equal to DC and solve for x by subtracting 3x from both sides, and then subtracting 12 from both sides, and we get x equals -4. And in the last example, we're going to set x equal to 2x minus 3 since QS is the angle bisector. And we're going to subtract 2x from both sides. It's going to give us -x equals -3, so that means positive x equals positive 3. Plug that into the expression for SP, and we get 2 times 3 minus 6, or 3.